Let's solve this problem. Let's see today's Leetcode problem. Jump game 5 or 6. What is that? Look at me. I don't even know Roman numbers. Um, what I'm going to do is I'm going to think as if I'm in the interview, and I'm going to solve this problem. So, and I'm going to guide you, or let's say talk through these problems as if I'm talking with the interviewer. So you are the interviewer and you have asked me this question. So let's see how should I approach, or how should anyone approach this problem, because this is the question that I've never seen before. Um, so first thing I would like, as a I'm going to ask for like 2 minutes to go through the problem, understand it, try to understand it, and ask any questions if I have. So let's see the timer. This 1 minute. So I'm going to take exactly 1 minute, and uh, yeah, we'll talk. You are given zero indexed integer array nums and integer k. You are initially standing in one move. You can jump at most k steps forward without going outside the boundaries of the array. That is, you can jump from index I to any index I plus 1. Okay, inclusive. You have to reach the last index of the array. Your score is sum of all nums of j for each j you visited in the array. Return the maximum score you can. Yeah, so I understand. I'm trying to understand this question. So what I usually do is I talk through some important things in at least I think I should talk in the interview. So first thing, I will ask, or I will tell the interviewer that okay, what's the input in this in uh, in this question, right? So the input is going to be an integer array which is zero indexed. Okay, zero index. Obviously, it's written here on the left side, but still I try to write it on my own, so that it's really important that you don't miss some edge cases. So try to understand. It is just an integer array. That's the input, and there is one more input, which is integer k. What's the k? Now you should understand what's the k here. You are initially standing at, okay, that's fine. You can jump at most k steps forward without going outside the boundary. So k is how much bigger the jump you can take, maximum jump you can take. So let's say it's 2. So you can take two, two at most two jumps, like 2 unit jump, or you can take even 1 unit jump, right? If you take 0 unit jump, you will never go forward, so that's not gonna count. So you can take 2 unit jump, 1 unit jump, or if it is 5, then 5, 4, 3, 2, 1, any jump, but it should not go out of the boundary. So yeah, so that's what it's saying. At least for now, I'm understanding it in this way. So I will talk with the interviewer, and if I'm mistaken, he will at least tell me, think harder or something, like, yeah, I think it's not correct. It's something different. So right now, I think that's correct. Okay, so integer k. Uh, Now the most important thing you should write is what's the output going to be. Sometimes in any problem, what happens is you think, oh, so this question, the output must be an array or something. But I have done this mistake hundreds of time, or not in the interview, because I have never given hundreds of interviews, but yeah, while solving problems, that I think out this is the output, and I try to solve in that way, and then I understand that okay, this is not the output. So let's see what the output is, or what they want. Return the minimum score you can get. So here the output is only going to be integer result or something, which is uh, which is like maximum score. See, I said minimum, but again, if I read here, it's a maximum score. So yeah, you can catch many of your bugs or initial assumptions if you write down the things. Okay. Now another thing is you should not do this like directly going. You should keep talking while writing these things. Now another thing I say is, okay, I ask the interviewer, so yeah, we have the integer array as an input and k integer k, right? So what is the size of the array? Can we assume it's going to be some limit, or it's gonna be a huge, or it doesn't matter? So most of the time, the array size or some the size of the input, interviewer will say it kind of doesn't matter, or don't worry about it for now. Just assume it's okay. It's taken care of. So in that case, it's fine. But in some cases, like if you have to use recursion, or it's a brute force solution, then the size matters. And at that time, most of the interviewers will say, yeah, I think it's not going to be more than 10 elements or 15 elements. So if they say that, you understand that, okay, I can just go for brute force solution. Okay, so in this case, let's say the interviewer answers me like, yeah, you don't have to care about it. So doesn't matter. I'll write that. And size. And next thing I ask about the values, because this is also very important. In case of arrays at least. So vals, I write down these things. So what it means. So I ask, so we know that I know that this is an integer array. So do you think we can have negative numbers? Yeah, probably. You will say yes. You can assume that. And what about I'm assuming we can also have a zero in it. He will say, yeah, yeah, that's absolutely right. And what about duplicates? Do you think we can have duplicates, or it doesn't matter? He'll say, the the thing is, the interviewer who is asking this question, he has asked this to like tens or 50 people in the past, so he knows in and outs of this question. So if he knows that duplicates are present or they might cause problems, so this the assumption is not good to have duplicates, he will tell you. But if if you know, it's very important that you ask. And I have made some mistakes by not considering duplicates in the array, because in most of the cases in examples given, right, there are not no duplicates present, and those are the edge cases. So you have to have, or at least you should talk these things in the interview. Okay, so I think I'm taking a lot of time here, but this should happen in like at most initial 5 minutes, as I'm explaining it to you as well. This timer is 8 minutes now. Um, Also, I just don't start the coding right now. So I'm just understanding what are the inputs, what are the outputs, um, the main problem, and then size matters, or what are the values in it. That's it. Then I'll write some few things. So test cases, um, uh, edge cases. I'll just write it down in and I will say that we'll come back to this, but let me write down a few things so that I don't miss out anything. So I'll go design, code, and time, space. So so we'll come back to this. I'm not thinking about any test cases or edge cases right now. Let me try to come up with the algorithm first, and then we'll go through this later. Yeah, so now now I'm going to try to understand the problem, come up with the algorithm, and honestly, I'm just gonna do this for when this timer is like till 13, and if I don't understand it in 13 minutes, then till 13 minutes, then we'll check the solution or something in the discuss. But yeah, let's start. Okay, so this is the nums array. I am at the index 0 and integer k is 2. So the most important thing is you start with the examples given. Don't create your own examples. Start with them, and then for edge cases and test cases, you design your own um, examples. Okay. So again, standing at index 0, I'm standing here, and in one move you can jump at most k steps. So I jump here. Okay. Without going outside the boundaries. Okay, that is inclusive. You want to reach the last index of the array. So I want to reach 3. Okay, and your score is sum of all nums of j for which index j you visited in the array. So if I jump from here to here, here to here, and from here, the sum of these numbers. So 1 plus minus 2 minus plus minus 7 plus minus no plus 3, right? So you can choose your jumps forming the sequence 1 minus 1 4 3. Underline above the sum is 7. Okay, so we have to maximize the score. So in case of negative, we can so obviously we have to maximize the score, right? So positive numbers, most positive numbers will give us the right answer. So in this case, 4 3. So um, yeah, so what I'm trying to understand is now what kind of a pattern will go here. So after reading this question, I'm thinking about two patterns. One is greedy pattern, choose the positive numbers and go ahead, or choose a DP solution or um, DP solution. And one more thing that is coming to my mind is going backwards from. So we have to ultimately reach 3, right? So 3 has to be in the array. Now I can jump from 4 to 3 or 7 to 3. That's it, right? So what's gonna give me a maximum score? So if I add this or add this, right? So obviously 4. So now I add 4 to it, the result. Now here I check what's the maximum out of these two going backwards. Is this maximum or is this maximum? It's giving me this, and from here I cannot go here, but I can only go here. So that should be added, right? So yeah, okay. So now I'm thinking I do not even need this array. I can just start going backwards and keep the maximum array so far. mm, to to yeah, but but there is a issue, right? There can be a issue. This could be a wrong answer, so far what I'm understanding. So next thing I'm going to do is, okay, it's gonna take like 5 minutes. So think of this counter till 19 or something. I'm going to take this question and I'm going to paste it in this so that I can draw something. Okay, let's say this is right. and oh, oh, come on. And I'm also going to copy this solution because most of the time one solution is not good. Can white. Yeah, so um, now I'm going to draw this thing. For this, I have already gone through the question, right? So I just choose the maximum of previous two jumps or whatever jumps, and then I um, go there, right? Yeah. So obviously it's not a right question, and obviously as I'm thinking this as an interview, I'm a little bit panicked, and I know that I don't know the solution for this question. That's why I'm talking anything or doing anything, but this is how it's going to be. You have to be talking, and you have to uh, say what are your thoughts. Otherwise, there can be a problem. And second thing, if you are talking in the wrong direction, most of the time interviewer will just say something that is kind of a hint. Okay, why do you think that? And do you think what about this case? Do you think it will work in that case? So you have to think about that. Uh, so you know that you are going in the wrong direction if you're talking out loud, and if interviewers ask you some questions, that means he's trying to hint you something or pointing you in the right direction. So let's just say this is three. So so far I have three with me, right? And I can jump three. I can take at most three jumps. So to reach three, I can take any of these jumps. So with my algorithm, I'm going to choose maximum of it. So let's say I add four here. Okay. Yeah. So now from four, I can take to reach four. I need to take three steps, right? So I go back three and I check what is the maximum of these three elements. So that's 10. So I add 10, and sorry about that. Okay. So obviously this is you cannot go back from 10. So this is first element. So the answer will be 17, which is right, but I still think there is some problem with the test cases. So again, I'm going to go here. I'm going to take another test case, and I'm going to figure it out. If I am doing a wrong solution or something, because most of the time the test cases are not designed to give you the right answer initially. They're designed to obviously help you, but also you might miss some edge cases. So let's just start again at 3 minus 3. So I have to have minus 3 in my array, right? Because I have to jump there. Then what happens? 6, 3, and 3. So for me now the maximum out of no, I can only go two steps back. So out of 6 and 3, what is the maximum? Hmm. So it's 3. So add that. Out of 1 and 4, what is the maximum? I add 4. Out of minus 20 and 5, what is the maximum? It's minus 5. And out of 1, there is obviously 1. has to be included. Okay, so now you can see this cancels out. Plus 4 plus 1 is 5, which cancels out with minus 5, and the output is 0. So I think this solution is will work. Uh, Obviously, if k is like huge, let's say, so now the point, you have come up with the algorithm. Obviously, you don't know if it is best solution or is it brute force solution. You just think that okay, for three examples this is working, that means it should work. So you should be confident enough that this should work. And if it's not going to work, your interview, if he's helpful, he might give you some test cases that do you think in this case it will work or something. But let's say it works. Now I am assuming this will work. And now next thing is uh, just saying out loud the time complexity, or trying to calculate what will be the time complexity of this algorithm. So yeah, for this, in this case, I'm checking the maximum of these three elements. Okay, and then I'm choosing 4. So the the thing is, I need to have index of 4. uh, okay, and then from that index again I have to check 3 places back, and I have to maintain the index of largest in that, right? So it's gonna be like uh, I'm going to go through each element once, at least once, and then for each element I'm going to let's say find the maximum of those previous jumps, right? So at right now, what I'm thinking is the time complexity will be O of n number of elements into k, which could be wrong, and I'm pretty sure I might say some wrong complexities in kind of interviews, but approximately this is what I think. Now, while thinking of time complexity, I just thought of a edge case, so I will tell that. Let's say if k is 1, so what do you think the answer should be? The answer should be all sum of all elements. So in that case, you just have a single if case. If k is equal to 1, that kind of is an edge case, right? And you is that right? So if k is 1, you can only jump one back, one back, one back, one back, one back. So every element should be counted, and sum of them is the answer. Um, that's gonna be it. So yeah, that's the edge case. Another edge case is like you have one, two, three, four, five, six elements, and you have k is equal to 6. So you can you can jump to any element. So um any element, right? So you can just take positives from uh, all the jumps. Yeah, yeah. Um, Again, this is kind of a greedy solution. I am still having some doubts that this should work. I don't know why, but I have a feeling that I'm missing something. So for that, I'm going to create my own example. Okay. So let's say um, here I'm going to have similar example 10, Why it's not white, man? Come on, come on. Okay, let's take this. 10 minus 5 minus 2, 4, 5, 3. Yeah, so in this case, what should be the answer? It should be 3 plus k is equal to uh, k is equal to 2. Okay, so I will have at least 3 in it. Now I can take a maximum of 2 previous 2, so 5 plus maximum of previous 2, that is 4 and minus 2, um, which is 4. Uh, so 5 and minus 2 and 10. Okay, so I'm not going to waste any more time. I think this should work. So I'm going to start coding the solution. And this again, this is not an optimal solution. This is what I think is I can come up with within the time. So I will go ahead and start coding it. Yeah. So first thing is result is equal to 0. Let's say now what I have to go. Um, I have to start from back and then or can I start from the front? What do you say? Um, uh, let's take this example. I can jump 3, right? So in this 3, I take 10, then I can take, yeah, it won't work in that way. So now the question is how do you code this solution? And it has to be good enough, right? Hmm. Hmm, 10 minus 5, 2. Maximum is 10. Then I add 4. Maximum is 4. Then I add 0. Maximum is 0. Then I add 3. Is there a sliding window kind of a solution here? A better solution. So, mm, this is initial window. So I choose this. So next window is this. Uh, so I chose this. Okay. Uh, so next window is this. Okay, so what I will do is I will not waste any more time. I am I can sense this there is a better solution in one pass without checking elements again and again, but I cannot think of it right now. So I will just say that okay, I'm going to go with a correct solution as a priority, and then I'll try to optimize the solution. Okay, so let's see how can I go. Okay, uh, this is 0. So index current index is length of nums minus 1. Okay, and then what I'm going to do is for how should I do this? Cannot use for. Okay, so while current index is greater than 0, greater than equal to 0, what I'm going to do is result plus equal to nums of current index, right? That's the first thing. I added the last element, then find the largest in previous k elements, right? And set its index as current index. Okay. Okay. How can I do that? In Python, it's going to be I'm thinking and the largest in previous k elements. That's the question. That's the question. Um, how? How can I know? Let's just say I write a function which returns me a tuple. So what I'm going to say is idx so current idx is equal to find previous largest. Okay, and the values will be current idx comma k. Okay, If I write this solution, I'm pretty sure any interviewer is going to reject me. But again, it's not to just give optimal solution. It's just to show that yeah, you can come up with the solution. Okay, let's be positive. Yeah. And the previous largest. Okay, I get the index. I get the k. Yeah, and I have to find the largest, right? So let's say largest is going to be minus float infinity. Okay, and then for I in range idx minus 1 minus k till k till idx. So what is this is I have to start from k elements before. So let's say 0, 1, 2, 3, 4, 5. So idx is now 5 and k is 3. So 5 minus 3 is 2. So 0, 1, 2, right? From here till idx till 5. So from starting from 2 inclusive till 5, 3 limits. So I don't need this minus 1. Okay. So starting at minus 3 elements till the current index. Okay. Uh, Largest index as well. Let's say it's set to index. Okay. And if nums of I is greater than largest, update largest is equal to nums of I and L index is equal to I. Once this is done, I just need to return L index, right? So in this case, what happens is it starts at 2. Minus 2 is greater than largest, whatever the minus floating infinity is. So I set this index, then I go to this 4 is greater than minus 2, so I set that as last index. I go to 0 and then I come back here. Now there could be a problem that you are going beyond the limit. So what I can do is starting from max of this comma 0. You don't want to go beyond 0. So let's say you are here and you do minus. So 1 minus k is minus 3. So you start from minus to this. So that's not going to work, right? So I was good enough to find this solution, at least a bug. Let's see. Okay, I'm pretty sure this is going to fail, but for my uh, satisfaction, I'm still going to go ahead and complete this. Now what will happen is okay, and current index Will this keep repeating? Will this keep repeating? If current index break, and let's return result. Oh my god, I wasted 40 minutes. Okay, let's solve the bugs. Let's see. Come on. Oh, now you have to understand that when your test case runs, right? This is the most satisfying thing. And now you can just say code is written, time complexity is big O of n star k, not star dot k, and space. You are not using any extra space, so space is big O of 1. I'm pretty sure it will fail for multiple test cases. Oh, to my surprise, it's passing for this. But it will not pass many of the test cases because I know that this is not the correct solution. There has to be a better one. So we'll go through a discuss section and we'll find out. But let's see what are the test cases that it fails. Yeah, um, it's failing some big test cases. Um, okay, so without any more, let's check, discuss, and best solution that could we can find. Wow, this is crazy. I don't even want to read it. This one, um, monotonic queue. Yeah, it came to my mind, but I didn't think it's going to be. This problem is very similar to problem this. Okay, we'll see that. Let us ask the question: what is the maximum score we can get when we reach the index I? It is equal to nums of I plus maximum among the previous k, or less if we reach the boundary numbers. The idea is exactly the same as we use. Okay. Uh, Honestly, this kind of solution came to my mind, but as I said, the initial running through the test cases gave me a confidence that my solution will work. So I went with it. Yeah. So let's try to find out what this solution is doing. Let's DQ be the monotonic DQ. This is pretty standard algorithm, monotonic increasing or decreasing queue. Okay, is a DQ where element inside will always decrease. In fact, we keep indexes, not numbers. Okay, got it. Uh, so this is better because we are keeping the indexes. So while DQ and DQ of 0 is less than I minus k. This I don't understand. So the first element in the DQ is if it is less than I minus k. This has to be DQ of I minus k, right? Okay, we are keeping the indexes. DQ dot pop left. This line removes all outdated elements from the DQ. Yeah. Now I understand what this line is doing is, um, if you reach, so let's say if you are here and or let's say if you are here and in your queue you have all these elements so far added, but the k is 2, right? So you only want these two elements to be considered. So that sentence is deleting this element. So if index, we are checking here index and not the value at the index. Here we are checking value at the index. So now what this means is, uh, you you will only store the queue in decreasing order. So let's say now the queue is empty, so you will store 10 here. Let's take this example. Then -5. So it is decreasing. So you store -5. Okay. You -2 is decreasing. So you store -2. Now uh, now this is a limit. So when you reach here, obviously you can have still the limit is not reached. Okay, you have to add 4, right? But you don't add 4 here. That's the beauty. You add you before adding 4, if you add 4 here, this is not going to be strictly decreasing. It will increase here. So you pop this element, and you add 4. In our case, we'll add index, and then we go here. Now 0 is decreasing, so that's fine. Now once you're here, you cannot have 10 again. So in that case, the first line was deleting this 10 from the queue, and now top of the queue is 4. And I believe once you have used that, you should pop it as well. So yeah, and then you add 3. So you cannot add 3 because uh, this is 0. So you pop 0. There is no 4, so you add 3, and then you add top of the queue 3 and you pop it. So at the end the queue is empty. You have finished the scanning through the array, and you have the result. Okay, cool. And this line is doing that. So while dq and nums of I is greater than nums of top, the last element is greater than, then keep popping it. And once you have popped all the lesser elements, all the great, yeah, all the lesser elements than current element, you append that. Okay. Mm, mm, mm. So, uh, why you are returning nums of -1? Nums of why you are returning nums of -1? Okay, he's changing the array in place. Hmm. Yeah, this is something I didn't understand. I believe this is this this question has gone like 1 hour, so I should stop this video. and uh, submit this. Hey, it's a progress. At least you ran through initial things, right? Initial test cases. Sorry. Cool, cool, cool. Yeah. Uh, so yeah, bye. It took a lot of time. I should probably think of it as solving the problem in less than or less than 20 minutes. Yeah, that's the ideal thing for YouTube. But yeah, this is for my thing. Yeah, so ideally the interview is like 1 hour long. So anyways, see you. Always blue.